Hello and welcome to the series of RapidMiner videos. My name is Dr. Marcus Hoffman and I'm a lecturer at the Institute of Technology Blanchardstown and also the principal investigator of this project funded by the Irish National Digital Learning Repository. The series of RapidMiner videos was created in close collaboration with Ralph Klinkenberg and Dr. Ingo Merswa, the two founding members of RapidMiner. More videos as well as additional material to some videos can be found at www.rapidminerresources.com. I would now like to introduce Ralph Klinkenberg, who will talk you through this tutorial.
Welcome to RapidMiner. This introductory video demonstrates how to use RapidMiner for text mining. That is, how to load textual data into RapidMiner, how to pre-process it, and, for example, how to learn then classification models based on it. Before you can use RapidMiner text mining, you first have to install the RapidMiner text mining extension. You can do so by selecting the Help menu, selecting Update RapidMiner, selecting the text processing extension, clicking Install, and that's it. Here we already have the text mining extension installed, so we don't need to do that right now. We can start a new process, select the repository where we would like to store the process, specify the process name, and we can get started. To load documents from files, select Process Documents from Files, drag it into the design view, and now you can specify the parameters. So first we have to specify where to read the documents from. Here I would like to read it from two directories. First I have to specify the directories where to read the documents. Here we have a two-class newsgroups classification problem, one group about graphics and a second group about computer hardware. Now we can also give internal names to those groups, and then we're done. So now the system knows where to find the documents. You can also select a weighting scheme. So when the texts are processed, they're taken as an unstructured, ordered list of words, and they're transformed into something that you can also word order, called the Back of Words model or document vector model. And the documents are represented in vectors where each position corresponds to a fixed word over the whole corpus of documents. And for each document you count how often the words occur in that document. There's different ways for doing this counting. The simplest one being binary term occurrences, where you simply count whether a word occurs in a document, yes or no. If you want to also count how often it occurs, this is called term occurrences. If you want to count the relative term frequency, that is the fraction of the document length occupied by that particular term, this is called term frequency. And the most advanced scheme is called TF-IDF, which stands for term frequency inverse document frequency. So the term frequency is computed as before. It's the fraction of the document made up of this particular word. So the higher the term frequency, the more often this word occurs in this particular document, the more characteristic is this word for the document, so the higher the weight should be. And the inverse document frequency is based on the document frequency, which is the number of documents that the word occurs in. And if it occurs in too many documents, it's not so characteristic anymore. So the inverse document frequency, that is 1 divided by the logarithm of the document frequency, is taken as a factor to downweight words that occur in too many documents. So now that we described what happens to the documents in the loop, like where they come from and how the vector creation should be done, we also have to tell which steps to do inside the loop. So I double click on this operator, move to its inside, and specify, well, these documents should be tokenized. That is, the text should be cut into individual terms or words. There's different separators I can use, like non-lambda characters like white spaces, punctuation symbols, and so on. I could also specify my own separating characters. or use regular expressions, but here we stay and select non-letter characters. You could also add other operations, like for example some stop word removal, like English stop word removal, which would remove articles, pronouns, conjunctions, and so on. So now, if I go up again, this is the first text mining process. We could also go back in, place a breakpoint after each step. So I right click with the mouse, select breakpoint after, so I can watch the process work with each document. If I press run now, so if I press run now and look at the tokenized documents, I can see the original text here at the bottom, and I can see how it looks like after the terms have been extracted, and whenever the color changes, it's the next word. If I press continue, see the same for the next document, the next, the next, the next, the next, and so on. So if I now remove the breakpoints again, the process will run to the end. And I can see the complete word list, that is a list of all words occurring in all documents. And I also see the document collections. So what I can see is the word list, that is a list of all terms occurring in the documents. And I see the example set containing the document vectors, that is one line for each document and one column for each word, with the counts, the TF-IDF values in the fields of the table, and also some meta information, like for example the file location, file date, and so on, and of course also the group or class that this belongs to, indicated by the label attribute. If you now would like to generate a classification model based on this data, you can go back here, go to this super process, select the classification model, and for example select the knife base learner. And this would then automatically learn a text classification model in the form of a Bayesian model to separate between the two classes, graphics and hardware. And looking at the distribution model, you could, for example, look at individual words and select particular words like, for example, graphics. And see how well they separate. In that case, you see that graphics documents have, on average, a higher TF-IDF value for this particular word than the hardware documents, but it might be the other way around for other words. If you would like to apply the same text classification model to other new documents, you would have to use the same text preprocessing, and you would have to reuse the word list generated by this process to make sure that training and test data have the same format. But this would be a topic of a more advanced video. Thanks for your interest.
For further information on RapidMiner, please go to www.rapidminerresources.com or www.rapid-i.com. If you are interested in upskilling, please go to www.itb.ie, where you will find more information about our distance learning MSc in computing science, in business intelligence and data mining. Many thanks to the Irish National Digital Learning Repository for funding this video.